you have for making sure your database stays up and running and servicing the applications that use it. And then finally, in the last module, we'll look at troubleshooting and maintaining a database and just one or two of the issues that you might find if you've got databases that you're operating on a day-to-day basis, and how you identify problems and keep those running smoothly. So a lot to get through. Looking forward to seeing what Christian has to say about this. I'll set a few expectations. We're assuming that you are a database professional and you have some SQL Server experience. So this isn't a course for someone who's never used SQL Server. We're kind of assuming you know your way around SQL Server Management Studio, you know a little bit of Transact SQL, and you're kind of familiar with the overall concepts of the database. And as I said, it's specifically designed for people who are pursuing MCSE certification in SQL Server. So those of you who are looking to sit the exam that corresponds with this course. There are some other materials that you might want to think about looking at to help you achieve those objectives. There's a number of Microsoft official curriculum courses that are delivered by our Microsoft certified trainers, MCTs, throughout the world and through our learning partners in the CPLS channels. If you are the kind of person who enjoys going to a classroom and learning from an instructor with other students in the same room, then that's a great route, and I suggest that you take a look at the Microsoft.com/learning website to get more information about those courses. And if you're the kind of person who views things online, and given that you're watching this, I assume you are, then have a look around the rest of the Microsoft Virtual Academy. There's a whole range of courses on SQL Server, everything from learning Transact SQL to basic SQL Server administration through to developing databases and this designing databases course as well. So I do suggest that you take a look at those courses. The one other resource that every SQL Server professional should be aware of is SQL Server Books Online, which is kind of a fancy name for the technology documentation is the word I'm struggling to find for the product. That's hosted both in TechNet and MSDN, and I'll just quickly show you how that works. So if you go to the MSDN site, in this case, in the MSDN library, buried underneath Servers and Enterprise Development, SQL Server 2014 product documentation, you'll find books online for SQL Server 2014. And all of the documentation, not just how to use the product and what the features are, but also good guidance and techniques that you can use to make the best of SQL Server. And exactly the same information, if you're more on the infrastructure side, is available within the TechNet library as well. So the documentation lives in both places. You can also download a local version. When you install SQL Server, there is an option to install the product documentation locally, which you can do. But I would say that it is periodically updated, so it's worth getting used to using the online documentation to get the latest and greatest information there. So you're on the MVA, you're at Microsoft Virtual Academy. As I said earlier, there's a whole bunch of other courses. Make sure you make the most out of the Virtual Academy. Have a look around the site, make sure you've signed up, your profile's up to date, and add things to your learning plans, and make sure that you're getting everything you can out of the MVA community. So with that, we're ready to start properly looking at the course, and we'll start on Module 1. Christian, I've been rabbiting on for too long introducing things, so I guess it's time to hand to you and get you to tell us what we're going to talk about in terms of managing a SQL Server environment.
Great, thanks, Graham. I just wanted to iterate first of all that Graham mentioned this course doesn't cover the complete syllabus for the exam, and it's been really great fun for us to really cherry pick some of the best bits, some of the bits that are maybe misunderstood or harder for people to study on their own. So hopefully that you'll gain something of interest and something of useful and some exam tips as we go along the way.
Fantastic.
So starting off with Module 1, Managing a SQL Server Environment, the first thing I wanted to talk about was SQL Server Agent Performance Alert specifically, because I think it's something that's overlooked for many DBAs and SQL Server professionals. Okay. Then we're going to talk about managing resources with Resource Governor. And then we're going to move on to auditing with SQL Server Audit. And then finally, declarative management with policy-based management. So they're all really, really quite powerful tools that are sometimes undersold, I think, within the SQL Server professionals and community. And they're definitely featured within the exam syllabus. So they're well worth having a good look at.
Great stuff. Okay. Let's dive in then on performance alerts.
Perfect. So SQL Server Agent performance alerts. So first of all, defining an alert. So an alert is a predefined response to an event. And they can be triggered by logged SQL Server events, WMI events, and specifically what I wanted to talk about here is SQL Server performance conditions. So we can actually hook SQL Server into some of the performance monitor counters and drive some alerts based on that, which is really, really quite a powerful way of configuring some automation.
Great, sounds good.
So, and once you get these alerts, they can then notify an operator, so you can get an email that something's gone wrong, but more often you'll use it to start another job, which is what we'll see in the demo.
So you can proactively fix the issue before it becomes an issue.
Exactly.
Kind of thing.
So I get an alert that something's gone wrong, or more likely is what I want is something looks like it's going wrong, and I'll use that to trigger a job to do something about it.
All right, I like it. Okay.
Should we have a look?
Let's take a look.
Great. So you can see on my screen now, I just have a local installation of SQL Server. I have SQL Server Agent started. So this is where we're going to define these alerts. So you see I have an alert object here, and I'm going to create a new alert. So this alert, I want to notify me, or I want to do something when a transaction log on a database is starting to fill up. So let's call this people. So I've got a database called people log filling up. And now I'm going to drop down here. So rather than a SQL Server event alert, I'm going to use this performance condition alert. And what this will allow me to do is to list out all of the SQL Server performance conditions that you would see in Performance Monitor.
Oh, okay. So the same things that I would view in a chart, or I would record in a log if I were using perfmon to monitor. Okay.
Exactly. So what I'm interested in here is the databases object. And within databases object, I'm interested in %log used.
Okay.
And the instance of that is the people database. So that's a list of the databases that I have there.
All right.
So let's say I want an alert if that rises above 40%. So what I'm trying to do here, I'm not saying when it's full and everything's broken, send me an email. I want to proactively measure this performance condition so I can do something about it before things go wrong.
So this might be a database that day to day there's a few transactions, you're not expecting anything dramatic, but should there suddenly be a whole bunch of activity and the log starts to fill up before the thing crashes to a halt because we've run out of disk space, you want to be alerted about that.
Yeah, exactly.
Okay.
Exactly. So, I mean, this may be quite a low threshold, but for the purpose of the demo,
sure,
it's sufficient. So now the response. So notice I could have a notify operator and/or notify operator. I've got myself defined as an operator there, and I could send myself an email.
Okay.
But what I'm really interested in is this execute job capability. Now, I already have a backup job defined to back up the transaction log for this people database.
Okay.
So I'm just going to select that as the alert condition.
And of course, backing up the transaction log will truncate it.
Exactly. So if we set this alert up now, have a look on perfmon. So I have %log used, so this is the counter that we're using for this alert condition. Okay. And we're just bumbling on about 15% used there.
All right.
So I'm just going to run a query to insert some data in here, which is hopefully going to add some. So we can see it spiking up there. Yeah. So we've gone up to 85%. So we should have triggered that alert. And if we right click, now we'll look at the properties, we've got some history, and so we've had a fire occurrence there. And if we have a look at perfmon, just as the log backup completed, we've gone back down to 15%.
So what we've done then is design a system that spots a potential problem before it becomes a problem.
Exactly.
And resolves it. And obviously the operator that you had in there, the option to notify an operator, these aren't exclusive. You might still want to be notified that this happened.
Exactly.
But you don't at least then have to, leave the house in the middle of the night and come into the office to fix it, because it's going to do it for you.
And this is a very simple example, and typically you wouldn't manage your environment this way. But what I wanted to show you is the flexibility of the different things that you can do with this. The best example of where we've used this technology in production environments in the past is where we've had a problem with tempdb transaction log filling up. Mm-hmm. And it needed the checkpoint process to run. Now, the checkpoint process is a marker in the log, mm-hmm. which guarantees that all the dirty pages have been flushed to disk. And the automatic checkpoint process goes through all of the user databases and then the system databases. So we had this recurring problem with a customer that had lots and lots of databases, lots of activity, and the checkpoint process took so long to get down to tempdb that we were running out of log space there. So what we did, certainly in the short term, while we were looking at the usage of tempdb from the application perspective, is to create this performance condition alert that when tempdb log hit 50%, hit 70%, we would run a job that issued a manual checkpoint
statement, right?
In addition to this automated checkpoint process, and it was very, very effective of avoiding outages of running out of tempdb log space.
Great, fantastic. All right, well, let's switch back to the slides and move on and look at something else. Okay, so we've talked a little bit about having a job that runs in response to an alert that's triggered by a performance event. I want you to tell us a little bit about Resource Governor on a slightly different tack now, but we're talking about having databases with perhaps competing workloads that are competing for resources. Yeah. So tell us a little bit about how we can manage that with Resource Governor.
So Resource Governor is a very, very powerful feature within SQL Server that came with SQL Server 2008, and it allows you to classify workloads that are coming into SQL Server. And in this example here, as we're building out the slide, so we can classify it by user, we can classify by internal SQL Server workloads, by application name, so it's quite powerful about kind of carving out this, classifying the workloads.
So this is my way of differentiating between that workload's in that particular database, or it's that application, or it's this user, or it's running at this time, or whatever it might be. Okay.
Exactly. And then the next stage of setting up Resource Governor is that you would classify, however you classify these workloads, you'd assign them to a workload group. So typically we're looking at these user-defined workload groups when we're setting up a Resource Governor configuration.
And there's already an internal and default workload group defined for you, but we're really talking about creating our own that help us group together applications with similar resource requirements, I guess.
Yeah, exactly. Okay. And then the next stage of this are resource pools. So this is where you're assigning a percentage of resources to specific workload groups, so you can manage who gets what within these resource pools.
So I'm prioritizing in that case. I'm basically saying that group of applications is going to run at a higher priority, or it's going to have better access to resources than say this other low priority workload. Or
yeah, exactly. So we can separate out production workloads from ad hoc reporting. It may be a scenario where you can allow for reporting in a production environment, but you put a cap on the resources that those reporting workloads can use. And one of the changes for SQL Server 2014 is to allow IOPS, so that's IOs per second, so to restrict the storage performance based on these workload groups and resource pools, which we couldn't do before SQL Server 2014.
Right, okay, so it's preventing one workload from stealing all the resources that another workload needs.
Yeah.
I guess one other point that's probably worth making is, although we're setting maximum values here, if there is no compete situation, then we're not throttling that that application or that workload all the time.
Exactly.
It's only when there's competition for resources that these limits are applied. Yeah.
Yeah.
Okay.
Yeah, exactly. Shall we have a look?
I guess you better show us. Yeah. Okay.
Great, so I'm going to start off here by restricting the resources that this instance can see, just to make the configuration of Resource Governor more apparent.
Okay, so this isn't actually required for Resource Governor, this is just really to throttle the hardware resources.
Exactly, just to make it a bit easier to understand and a bit visual. So I'm restricting the instance of SQL Server to one CPU with the affinity mask configuration.
Okay.
I have 4 CPUs on the server, and I'm just throttling the amount of RAM that SQL Server has as well.
Okay.
Make sure that takes effect. So first of all, I'm going to create 2 resource pools, one for production workloads, called pool production, and everything that's production is going to go into there. And then I'm going to create another resource pool called pool ad hoc, which everything else is going to go into.
Okay.
So now I'm going to create 3 workload groups, assigning each one to one of the above resource pools. So I'm going to create a group called production, which is going to use pool production. And I'm going to create a group called reporting, which is using ad hoc, and also a group called IT, so group IT, which is also using ad hoc. So we've got 2 workload groups, part of the same resource pool.
Okay, so we've got a pool of resources that are available to whatever workload groups are assigned to them. And in this case, we've got one workload group for production applications that are, we need to have running all the time. They're mission critical. And we also have workload groups for people doing ad hoc reporting or for IT doing operations within the database server. Okay.
Exactly. So the next stage, because I'm going to classify these workloads by user account, I'm going to create 3 different logins here for production, reporting, and IT.
Okay.
They already exist, so that's fine.
That's fine.
So now I'm going to create the classifier function. So this is, if you remember from the previous slide, this is how, when the connection comes in, SQL Server is going to determine which group to put your connection into.
So this is at the session level. Every time a session is established, it gets assigned to a resource group, which in turn has an associated resource pool. Okay.
Exactly. So first of all, I'm using this login name here. So I'm using suser sname to be able to return the login name of the user that's connecting. So if you are user production app, then I'm going to put you into group production. If you're user reporting, I'm going to put you into the reporting group, and IT into group IT.
What happens if you're none of those things?
Then you'll go into the default resource group.
Okay. And of course, in this example, we're using the login name of the connection, whatever the identity of the connection is that's establishing the session. But of course, just to reiterate, it doesn't have to be that. It could be the name of the application. It could even be something like the time of day. So jobs that run overnight where you want to prioritize, let's do the backups during those hours, we can assign them to a resource pool at certain times of night. Yeah?
Exactly.
Okay.
So now we're going to attach this classifier function to the resource governor.
So this could be, I mean, basically you've created a function. It could have any name. You can create any function you like. It's in the master database. And then you just tell resource governor, that's the function I want you to use as the classifier function.
Exactly.
Okay.
And make those changes effective. So now I'm going to switch over to Performance Monitor, just so we get a visualization of these, the effect of this. And I'm going to find a group called Workload Group Stats, CPU usage. So now you'll see that I have these 3 different groups that I've created.
In addition to the internal and default groups that are already
Exactly.
there. Okay.
So we'll add those in, and that's going to show CPU usage by group.
Okay.
So if we just change these slightly to make the lines a bit thicker so it's easier to see.
And of course, at the moment, they're all at 0 because nothing has connected and been assigned to any of those groups.
I haven't put on the workload yet. So for the workload, I have a batch file here just to be transparent about what's going on. And within this batch file, I'm running some basic CPU crunching T-SQL, but I'm connecting in with SQL CMD as the user production app to run this CPU killer as reporting and as IT.
So we're effectively spinning up one instance of each of those types of user. Those then, through the classifier function, when they connect, will be assigned to the appropriate resource groups, and those resource groups have a pool of resources that they can draw upon.
Exactly.
Okay.
Exactly. So if we start this off now. Move this across so we can get a good view. So we're going to start production workload first.
So we see the
green lines coming up.
Just let that come across and join again at the beginning. There we go. So that's running along fairly consistently. It's getting its CPU resource.
And then we're going to start reporting workload. So you can see now we've got 50% each. So the reason this is topping out at 25% is actually because I've got those 4 CPUs on the box.
So it's a quarter of your overall CPU.
Exactly. Yeah. And then finally, I'm going to start the IT workload. And you notice that it's dropped down again here. So this is because we've got an even distribution here, each workload is taking a third of the CPU usage.
Okay. So no one workload is starving any of the others of CPU resources. Okay.
So if we switch back to Management Studio, and I'm going to change this. So let's say production workloads were suffering based on the fact that we had an even distribution of CPU. So I want to give production more, and to do that, I'm going to change ad hoc to have a maximum CPU of 50%.
So we're throttling the ad hoc pool to not starve out of resources, but to say, hey, you get a maximum amount of resources. We're prioritizing resources for the other pool over this one.
Exactly. So when that goes through here, what you'll notice is the tip.
It's just coming on
and you can see that change here. So now the green workload, which is production, is using a lot more CPU, and the ad hoc pool that we have for everything else, and in this case it's reporting and IT, are sharing that bottom 50%.
Oh, great. Okay. And what we're looking at here is obviously CPU resource utilization. The same rules apply. There are other things we can limit. So there's memory, there's IOPS we talked about earlier on. We can reduce the amount of IOPS that any one workload gets. So we can really characterize the different resource requirements of our various workloads and then prioritize them accordingly.
Yeah, exactly. So one final point on here. So let's imagine this scenario where what we've done is restrict the ad hoc workload so that production can have a few more resources. But let's imagine that the marketing team that are assigned to this reporting group running their reports, they're not happy that they've lost some resources because their reports are running slowly.
Okay.
So within here, what we can do is to assign the reporting group to have a higher importance.
So we're now, if I'm understanding this right, we're now within that pool prioritizing the different workload groups.
Exactly. So we've got 2 groups within the ad hoc pool, and what we're saying is reporting is now more important than ad hoc. Okay. And if we have a look at perf1, you see this has adjusted it again, so that IT, poor IT, sat in the bottom there.
Of all the groups that would be starved of resources.
I know. So you can see how it's very, very flexible in how you can assign these resources. And it's a great way for me to be able to provide scenarios where you can have mixed workloads in an environment, and you can allow reporting, but you can restrict the resource that it can use so things don't get out of hand.
And of course, if any one of these workloads ends and there's no longer a competitive situation, then actually, it doesn't mean that if there's spare capacity on the box that the workloads won't use it.
Absolutely. And we can simulate that by killing one of these, and it will readjust.
Yeah, we can see that the others go back up again. Yeah,
exactly.
Great, thanks very much. Let's switch back to the slides and carry on. Okay, so we've talked a little bit about having alerts that trigger actions or jobs that we might want to have to respond to performance alerts. We've talked about using Resource Governor to prioritize different resource access for different workload groups. The other thing you mentioned right at the beginning was Audit, SQL Server Audit. So let's take a look at that.
Yeah, so again, the SQL Server Audit feature is a very, very powerful tool within SQL Server, which does, as its name suggests, allows you to audit activity within the database. And it's a very, very flexible framework for you to pretty much audit anything that you could think of within the database. So we can audit server and database level activity. We can record this audit data into the application log, to the security log, or to a binary file.
Okay.
So the most secure place to put it would really be the security log, because you've got to have elevated permissions within Windows to be able to access the security log.
Okay.
And the components that enable this is SQL Server Audit, which we'll look to define first, and then we define a server audit specification and a database audit specification. Okay,
so I've got those two different levels of events that I can audit effectively.
Exactly, yeah.
Well, once again, let's move across and see this on your machine.
So if we have a look under Object Explorer here, what we're looking for is under security. Mm-hmm. So we're going to define an audit. First of all, let's call this My Audit.
Highly original naming.
Absolutely.
Yep.
Keep it simple. And I'm just going to dump that out. So I'm going to use a binary file as the destination. You see if we drop down here, we could use the security log and the application log, albeit I would need to ensure that SQL Server had access to be able to write to the security log.
Yeah.
So I now have an audit defined, albeit it's disabled. Now I'm going to create a server audit specification. Let's call that My Audit. Can you guess?
Yeah, there you go. My Audit specification. Yeah.
There we go. And I'm going to link that to the audit that I've just created.
Okay.
So now the actions that we're looking to audit, I'm going to, let me just check back here, database role member change group. So what I'm doing is setting up an audit here. If any members of groups change, I want to write that out to a file.
Okay, and you could presumably add multiple action types into this one audit spec. Yeah.
So now I'm going to enable the server audit.
Okay.
Enable the audit specification.
So that two-level granularity I've got there, then I could have multiple specifications that are connected to the same audit.
Yes.
And I could enable them or disable them as and when I'm required. So if I think there's something a bit suspicious going on, I might enable an audit specification that ordinarily is not enabled.
Yes,
right.
Yeah, exactly. So for the purposes of this demonstration, what I'm going to do is to create a new login called Hacker, with the password if you don't know I'm here. Don't tell anyone. And then I'm going to create a database user in the people database. It already exists, so that's fine. And I'm going to, let's change this just in case it's already there, to data writer. So the data writer database role, I'm going to add the hacker user.
So you've changed role membership, which is one of the things we were auditing.
Exactly. And if we have a look now, so we can use this function, so fn get audit file is how you can programmatically read this binary file.
All right. So I can query it almost like it's a table, really. I'm querying that file and getting the data back.
Exactly. So we can see here, if we have a look, so we've got in the people database, we've got the DB data writer role, and there's been an alter role to add hacker.
So I now know if I'm looking at this log file, I know that that's happened. So
and you could generate alerts based on the contents of these audit specifications. And a really nice area where we've used this with customers is around the changing of code. So we have this, as it's quite difficult to do, many of our customers, developers would have access to production, heaven forbid, to troubleshoot production data issues, if you like.
Sure.
But for some of these customers, we had this scenario of developers have access to production for valid reasons to fix data problems. While I'm there, let me just change these stored procedures, which then cause performance problems, and because there's no tracking, there's no change control.
Sure.
So rather than change the way the business worked, which is quite a difficult thing to do, we made people accountable for those changes by auditing. So what we set up is that whenever any objects were changed, so any stored procedure objects were changed, we will write that to an audit file, and then we set up alerts to email out what had changed and who's changed it.
Okay.
So lo and behold, changing the behaviours of people that suddenly they were, we didn't stop them doing it, but suddenly it was very visible when people were making changes. So people then made sure that they had justification for changes that they were making. So it's quite a flexible auditing tool.
Yeah, so I mean, we can see there the session principal name. It logs the user, the Windows identity of the individual user who performed the action. So that's always logged. Can I actually just do one more thing? Could you bring up the properties of my audit, or your audit, as I guess it is? There's one other thing that I wanted to pull out from here. We have an option in here. You'll see it on audit log failure. So if there's something happening to the audit log, if it fails to log, we can carry on, but then we've lost auditing. Yeah. Or we can have it shut down the server, which is perhaps fairly dramatic, or just simply fail any operation that's going to be audited. So what we could do is to prevent something happening that we either want audited or we don't want it to happen. Yeah. We've got those options there as well.
Yeah.
Okay.
Good point.
And let's take a look at the last thing we wanted to look at in this module, which is a bit of a mouthful: declarative management with policy-based management.
Yes.
So, tell us about that then.
So policy-based management is the feature, and it enables you to define and implement policies for SQL Server, which again is another powerful tool that is underutilized, I think, certainly by SQL Server professionals and the customers that we work with. And essentially, so the architecture for this can be a little bit, certainly for the exam, you need to get a grasp of the terminology that we use around the architecture of policy-based management. So first of all, we have this concept of facets. And facets are really groups of properties. And then we have a condition, which is the required state of the property. And then finally, a policy itself is the complete package, which consists of conditions, facets, targets, evaluation modes, and server restrictions.
Okay, so facets, I guess, are just attributes of some aspect of the system that I want to that has some kind of setting that could have whatever values that setting could have. The condition is the value we want the setting to have. Yeah. And then a policy is really what enforces those settings across the system.
Yeah, so it's this kind of grouping.
Okay. Well, that was a quick set of slides. Let's dive back to your machine then.
Perfect. So we're going to expand the management hierarchy here and have a look at policy management. So you can see I mentioned these facets or these groups of properties here. And what I'm going to do is based on the database performance facet.
Okay, so that's the aspect of the system we're concerned about.
So if you have a look in here, so these are the properties contained within the database performance facet. And there are some overlaps between facets, but essentially what you're doing is hooking into a facet to enable you to evaluate the properties within that facet.
Okay.
So, and I'm going to right click database performance, and I'm going to create a new condition. So remember I said condition is the required value, so this is what we're looking to evaluate.
Okay.
And let's call it our health check condition. So this is something that we've used in the past with some customers around automating database and server health checks to set this all up and have it automatically notify of changes in non-conformance. So within this database performance facet, so I'm already in that context. So what I'm going to take is the auto close field. So auto close is a database option. Whenever we see this enabled, it's typically because SQL Server Express, the free edition of SQL Server, I've got a number of instances running on my laptop for various updating tools. If the database isn't accessed for a while, it will automatically shut down to save resources.
Okay.
But in production environment, we don't really want this, because if you try and access that database, there's going to be a delay, there'll be timeouts. So in a production environment, we don't want auto close to be on.
Okay.
So we're going to look for auto close to be false. Auto shrink. So again, auto shrink is periodically shrinking to remove free space in a database file, but we really want to control and be deliberate in how we manage file sizes within SQL Server.
Okay.
So I want that to be false as well. We've also got collation matches model or master. So the reason we would check for this, so collation is really the ordering of data within the database.
The character sets and the order and sorts.
Exactly,
and so on,
exactly. And it's set for the instance of SQL Server when you install SQL Server, and that will govern master model tempdb.
Okay.
Where this can become a problem if your application isn't collation aware. When you're developing your application, you're creating temporary tables. Those temporary tables are created in tempdb, and that has the system collation. And if your database has a different collation and you're not aware of that, it can cause problems with string comparisons.
Right. I see. Okay.
So we would look for the collation of the database to be the same as the instance.
So that one should be true in this instance.
Yes,
Okay.
yeah. And it's not that it's categorically wrong, but we need to have a flag to say, are we aware that there's a mismatch of collations?
The point of this is your policy. You can use these facets to define whatever policy you want to enforce.
Exactly. And then finally, we'll have one on here for data and log files on separate logical volumes. So we can check to see, do we have the database data files and log files on separate logical volumes for manageability or performance purposes.
Of course, that's a best practice with SQL Server.
Yeah, exactly, exactly. So I've got these four attributes that I'm testing within my health check condition. Now I'm going to come up here and create.
I guess we need to have a policy that includes those conditions, yeah.
Exactly. So let's have our SQL Server health check policy, and I'm going to use this health check condition. I'm going to apply it to every database, again on the server that I'm evaluating this against. Okay. I'm going to run it on demand. So there are some properties that you can do not just on demand, but you can enforce. So a classic scenario is enforcing not using SP underscore as for naming store
So if I
procedures.
try and create a store procedure, there's an option to say, well, there's a policy that prevents you from doing this.
Yeah, so well, it will prevent you from using SP underscore as a prefix.
Yes.
Yeah. But in this case, I'm creating an on-demand policy.
Okay.
So now I have this policy listed. I can right-click and evaluate this policy against the local server, and it's showing me where I'm out of compliance for these policies.
Which appears to be across the board.
Absolutely. So we have auto-close and auto-shrink. That's what we want.
Okay.
But we've got a problem with collation and master and model and data and log files on separate logical volumes. Because I've only got a C drive on my laptop, this is why this is coming up.
Okay.
And I mean, this is really only scratching the surface of policy-based management. You can create a lot of logic in here to say if a database is this size, it should be configured this way. You can say I need to have optimize for ad hoc workloads as a server option, should be enabled on every server in my environment. And you could scan your environment and evaluate this policy against all the servers in your environment, and you can even fix that automatically from within this tool. So one of the health check policies that we set up for a customer several years ago, we evaluated these policies, and there were a couple of hundred servers that didn't have this setting enabled, and we were able to fix that automatically within policy-based management and multi-server management, which was really quite powerful.
And of course, if you've got a large estate of database servers and you are wanting to have consistent configuration across that estate, it can be really difficult to look at the myriads of different options on every single server.
Exactly.
Whereas here, you're, as we said in the title, declaratively saying, here's the policy that I want all my servers to adhere to, and then just checking that, verifying that across the estate.
And it's part of SQL Server. You already have this.
Yeah.
So it's really quite exciting when you get into the details of it and the flexibility of it. It's quite a powerful tool.
Great stuff. Okay. So we looked at quite a few things in this module. We started off by looking at SQL Server Agent performance alerts, and we had that idea of before something really bad happens, when it looks like it's beginning to happen, we can automatically fire off an alert that then triggers a job or notifies an operator or both and deals with that. We looked at the idea of having multiple workloads that might well compete for resources. And by resources, we mean things like the hardware resources and the number of IOPS against the disk, the memory, the CPU, all that kind of thing. We were able to classify those workloads into different resource groups. We're then able to assign pools of resources to those resource groups, and we're able to then use that to make sure that we're predictably saying there will be enough resources for these high priority workloads, for example.
Absolutely.
We talked about auditing with SQL Server Audit, so that the idea that we can define an audit that includes either at the server level, we create the audit. We then have a server level audit specification for server level events and a database level specification at the database level. We define which events we want to audit, where we want to audit them to, and then once that's enabled, if something happens that we want to keep track of, we know that it's happened, it's been audited.
Exactly.
And then just finally, we looked at declarative management with policy-based management, where you can effectively define the way that you want your systems to be configured, the way that you want your database servers to behave, and then either verify that, just validate the policy against the servers to find servers that are out of compliance, and in some cases actually enforce particular settings. So I can prevent people from naming store procedures with an invalid name, for example. Okay, so some great stuff in that module. Hopefully you've found some useful things there. If you are preparing for the exam, again, just to emphasize, not everything you need to know is in here. This is a really good starting point. These are the areas that you want to perhaps dig into and learn a little bit more about. And again, SQL Server Books Online, which I mentioned in the introduction, is a good place to start finding out more